Today we are going to start Unit 3 and we're going to be looking at how to classify triangles. So we're going to be able to compare and contrast triangles by angles and sides and also be able to solve for missing angles in triangles. First off, this is triangle ABC. So you name it with the angles or the vertexes. The sides are side AB, side BC, and side CA. And note, you can go backwards, so you could say side BA, side CB, or side AC. They don't have to be a certain order, but they are segments. And then the angles, you can say angle A, angle B, and angle C, since there's only one angle at each of these vertexes. Or, again, you could say angle CAB, angle ABC, or angle BCA. So classifying triangles by angles. The first triangle here is an acute triangle. And note that all angles are less than 90 degrees. We then have an equiangular triangle. And in this triangle, all angles have the same measure. And note that all of these are going to be 60 degrees. We also have an obtuse triangle. Because note, we have an obtuse angle, so one angle is greater than 90 degrees. And then we have a right triangle. And so therefore we have one angle of 90 degrees. So again, we have acute, which is all angles less than 90, equiangular, which is all angles have the same measure, and all of those are 60 degrees. We have an obtuse, where one angle is greater than 90, and a right, where one angle equals 90. The triangle sum theorem says that the sum of the measures of the angles of a triangle add up to 180. And I think most of you knew that from previous classes, but just to recap. So the name of this triangle, we could call it ABC, triangle CBA, but I'm going to call it triangle ABC. And note that we have this little symbol here, the triangle symbol, in front of it to show that it is a triangle. So is this acute, obtuse, equiangular, or right? You can see that we have one angle greater than 90, so it is obtuse. And then by the triangle angle sum theorem, we know that they add up to 180, and since we have 125, we can take 180 minus our 100 minus our 25 to give us angle X, which is 65 degrees. So note those theorems. The corollary that goes with the triangle angle sum theory is that the acute angles of a right triangle are complementary. So that means that what do they add up to? Angles A and B have to add up to 90 degrees if they're complementary. And so if measure of angle C is 90 degrees, the measure of A and B equals 90 degrees is what that means, since that they all add up to 180. So what type of triangle is triangle DGK? We see DGK right here, and we can see that we have a right angle, so therefore is a right triangle. Then we have triangle GKF. So GKF, that would be an acute triangle because all angles are less than 90 degrees. And then we need to find the measure of angle DGK. So DGK, if they all add up to 180, we can take 180 minus our 90 degrees for our right angle, and then minus our 40 degrees to get 50 degrees. Or you can note the corollary that our 40 plus this angle has to be 90, therefore it would be 50. And then now we're looking for the measure of angle EKF. So EKF, but note we have a straight line here. So all three of these angles have to be 180. So we can take 180 minus 65 minus 40 to give us 75 degrees. Following along, you should be able to finish these last two in a similar way, but angle KGF is 40 degrees and KFG is 75 degrees. So note why and go back and work those out and come in with questions. Now we're going to use the figure to the left to find the measure of angle 1. So using our corollaries and our theorems, we know that the sum of the angles has to add up to 180. So measure of angle 1 is 55 degrees. And then since we have vertical angles, angles 1 and 2 are congruent, so angle 2 is also 55 degrees. And then we know that the sum of the angles in this triangle have to add up to 180. So we find that measure of angle 3 is 70 degrees. Another theorem we have is the exterior angle theorem. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. So that means that the measures of angles A and B here have to equal the measure of angle 1. So another thing that we know is that the measure of angle 1 and angle C in our triangle have to add to 180 because that would be this part and this part, and since they make a straight line, they add to 180. So now we're going to find the value of x in our triangle. So with our corollary, we know that the sum of these two have to add to be this one. So we can set up our equation as 50 plus x has to equal 2x minus 15. Bringing our x's and our numbers to the same side, we can get that 65 equals x. Now we're going to look for angle SNB. So since we know that 65 is x, and we know that the sum of the angles has to add to 180, we can get that n is 65 as well. Also note that 65 plus 2 times 65 minus 15 is going to equal 180, I believe. Another way we can classify triangles is by its sides. So I'm sure you guys have seen these before. The first one is an isosceles triangle. Good luck spelling that. It's a difficult word. Special note that only two of the sides of the same length, so only two sides have the same length. So you can see here these two sides are congruent. The middle one is an equilateral triangle. So similar to our equiangular triangle, this is talking about all sides being equal rather than angles. So all sides are the same. And then lastly, we have a scalene triangle. And note that all sides are differing lengths. Or no two sides are the same length. So here we have a triangle, and if M is the midpoint of J side JL, what type of triangle is triangle JKL? So JKL, and M is the midpoint, which means that this segment is congruent to this segment. So we know that this is 0.75, making this whole thing 1.5. So we have a side of length 1.5, a side of 1.3, and a side of 0.75. Since no two sides are the same, that is a scalene triangle. And now we're going to look at triangle JKM. So if we have triangle JKM, we can see that all sides are 0.75 in length, so therefore that is an equilateral triangle. Last part here, if we have an isosceles triangle, triangle ABC, so let's draw one of those, where AB is congruent to AC, so that means that A is going to be our vertex, and we have B and C, so AB is congruent to AC. We want to find X, AB, and AC if AB is 3x minus 4 and AC is 4x minus 9. So since it's an isosceles, we know that these two sides are congruent. So we can solve for x by setting 3x minus 4 equal to 4x minus 9. Bringing our x's to the same side and moving our 9 over, we can get that 5 is going to equal our x. Now plugging that back in to one of our equations, for AB, we can say that 3 times 5 minus 4 gives us a length of 9, and since side AB has to be congruent to side AC, we also know that side AC is 9. Now, thank you for listening to this video, but again, note that we can classify things in different ways. So here we have some college teams, but then we also have some pro teams as well. So just a little more practice here. Find the value of D if KL is the base of the isosceles triangle. So we have an isosceles triangle and KL is our base. So that means that these two sides have to be congruent. So we have 12 minus D is equal to 4D minus 13. Solving for D, we can get that 25 equals 3D, 5D. So we can find that D equals 5. Another practice, classify triangle XYZ by the angles. So triangle XYZ, we can note here that this is a right angle because 40 plus 50 is 90 degrees. So we know that it is a right triangle. Here we have an exterior angle theorem problem. So we can find the value of x. We know that these two angles have to add to be 100. So we can set it up as 2x minus 11 plus 2x plus 27 equals 100. So combining our x's, we get 4x plus 16 equals 100. So we get that 4x is going to equal 84. Solving for x by dividing 84 divided by 4, we will get x to equal 21. And we already did that one. So find the value of x. If triangle MNP is isosceles with side MN congruent to NP, M2 is less than 5 times x, and NP is 7 more than 2 times x, and PM is 2 more than 3 times x. So let's first draw this out. We have MN is congruent to NP, so N is our vertex, and then we can have our M and our P. So these two sides are congruent. We have Mn is 2 less than 5 times x, so we have 5x minus 2, and P is 7 times more than 2 times x, so 2x plus 7, and PM is 2 more than 3 times x, so 3x plus 2. So finding the side lengths, we can set 5x minus 2 equal to 2x plus 7. Solving, we can get 3x equals 9, so x is going to equal 3, which means that plugging in to solve for the sides of our triangles, we'll get 2 times 6 plus 7. So we will get, or 2 times 3 plus 7, so 6 plus 7, we'll get this to be 13, and since these are congruent, this is also 13. Plugging in for x, we'll get 3 times 3 for 9 plus 2 is 11. So just a little more practice on those last few there. Thank you for listening. Rewind and come in for questions. Thank you.